Here is the question, and you see here it is written that you see converges to fx. This means that we can assume this Tylor series as fx if the interval is very small, that is x belongs to minus delta to delta, where delta tends to 0. Okay, now we impose the third condition. You see here the third one, and if I put x equals to 1 by n, then the same will be as you see here on the screen. F1 by n equals to f0 plus f dash 0 1 by n plus f double dash 0 factorial to 1 by n square, and so on. Okay, now you see f1 by n, you see here it is 0, so I place here 0, and here will be f0 plus f dash 0 1 by n plus f double dash 0 factorial to 1 by n square, and so on. Okay, so now you see that in the third condition it is mentioned that for all n belonging to natural number, it means that we can take n as a a very large number, and in other words we can say that we can tend n to infinity in this. So if you tend n to infinity, then you will get I write here in the red color, if you tend n to infinity, then you will have 0 equals to f0, and thereafter all the terms will be 0. Okay, so what we got f0 equals to 0. Okay, this relation and the process to get this relation f0 is equals to 0, I say this process as first iteration, and again I perform the same process. Okay, so I show you the same process. This time you see here in the same process you have to write this one, thereafter this one, and after that put the value of f0, then you will have 0 equals to, here you see f0, and that is 0, so 0, and thereafter plus, here will be f dash 0 into 1 by n, thereafter plus f double dash 0 by factorial 2 into 1 by n square plus dot dot, and so on. And here from this relation I can write 0 equals to f dash 0 plus f double dash 0 by factorial 2 into 1 by n square plus, sorry, not n square, 1 by n. Okay, plus, and so on. And again if you tend n to infinity, then this time you will have 0 equals to f dash 0. Okay, so here you have I show you in green box. The first iteration gives us f0 equals to 0. The second iteration gives you f dash 0 equals to 0. And if you perform in the same way the third, fourth, fifth iterations, then you will have the same thing. I mean f double dash equals to 0. In other word, we can say that the coefficients, the coefficient I show you in red. Okay, this is 0, this is 0, this will be 0. So this whole function will be a 0 function. Okay, so we got that the Tylor series of every function f is 0. Okay, now we go for the options. If you see the option, the first one, f0 equals to 0. Okay, it is true. Okay, f dash 1 by 2 is 0. Because the function is 0, then its derivative at any point will be 0. So it is true. And here you see option B is true, and but here you see the opposite. It says that it is not equal to 0, so this will be wrong. And again, since option A is correct, so option D cannot be correct. Okay, and one more thing I have to add. Okay, I have to add one more thing. There may be a question in your mind. That question is that I got this thing. I show you in blue. This one, this one, this one, 0. Assuming x minus del to plus del, where del tends to infinity, 0. But here the interval is different. You may question, but I say that this thing f0, f dash 0, f double dash 0, these are the constants. Constant mean it will not, this will not change. So for that interval 2, I mean the Tylor series, this series being constants, you have to put 0, and for that interval also the Tylor series will be 0. So now this question is over.